Hey everybody. So this is assignment 10. Um, assignment 10. And we're going to do some more with trig and triangles today, but I also want to do some talking about uh, solving trig equations and simplifying trig expressions by using our identities. A whole smorgasbord of opportunities for learning here. Okay, in fact, first, let's talk about this. I'd like to have a little review, um, and I think maybe you can help me. So, I've got theta, and I have 10 and 26. I'd like to, of course, it's always nice to be able to find this third side. And yes, it is a Pythagorean triple. 5, 12, 13. This times 2 is that. This times 2 is that. So this one must be this one times 2. But no, I actually want to know, what's theta? So here's what I see. I see opposite and I see hypotenuse. Which trig function is all about opposite and hypotenuse? Opposite and hypotenuse, that's tangent. So we could start by saying that the tangent of theta, no, why did you let me get away with tangent? Opposite and hypotenuse is sine. We know that. And this is 10 over 26. Okay, now this is what the sine of theta is, but I'm trying to solve the equation for theta. Now, next part is very important. You might want to highlight this, certainly draw a circle around it, put some stars. This is not sin times theta. Theta is the thing inside the sine function. So when I want to get rid of sine and have theta by itself, I'm not going to divide both sides by sin. That is a sin. Don't do that. No. In fact, what I really need to do is to use the inverse. Sine inverse. Sine inverse. Okay? These will cancel, leaving me theta. And over here, sine inverse of 10 over 26, or 5 over 13. Then we can pull out our calculator and say, hey, calculator, what's the inverse sine of 5 divided by 13? And I get 0.395. Now, what units am I in? Mode. I'm in radians. So just in case someone asks you about doing this in degrees, switch that mode from radians to degrees and check again. 22.620 degrees. Okay? Inverse trig. So we use the regular trig functions to find a side, but we use inverse trig when we want to find an angle. Okay? It's the only time I use the inverse trig buttons is when I'm looking for an angle. All right? So why don't we do another one of those? Since I've shown you how to do one, you could probably do this one. So how about this? And we've got 8 and 15, and I'd like to know theta. All right? Clearly, again, we're not on the unit circle, because in the unit circle, the hypotenuse is always 1, and the hypotenuse is the longest leg in a right triangle. So how did it go? Which trig function did you use? Did you say opposite and adjacent? So that must be tangent theta. Then what? How do we solve this equation for theta? Do we divide by the letters T, A, N? No, we don't. You know, there are going to be a bunch of people who do that on the test. Please, if they're your friends, don't let them. Don't let them. So we take the inverse tangent to both sides. These cancel, leaving us theta. And inverse tan of 8 over 15, I get something that I can't quite read. There it is, 28.072 degrees. And if you're asked in radians what that is, oh, let's take a look. And I get 0.490 radians. No, you don't have to get both. I'm just showing you that we can find both. And look, they don't look the same. That's another sort of important thing too. Okay, why don't you take, without looking at your notes, a minute to write down the reciprocal identities, the quotient identities, and then we'll move on to the Pythagoreans in a minute. But let's just do these first, okay? So there's 6 reciprocal identities to write down and 2 quotient identities to write down, and give it a go. No looking at the notes. You've got to learn these. Magic secret of trigonometry, number 1, draw a triangle. Magic secret number 2, know your unit circle values. And magic secret of trigonometry number 3, know your identities. These are the things that make trig much, much easier for people who don't know their unit circle values. This is a really, really, really tough thing, this trigonometry class. So please, take some time, use some flashcards, learn all these things. So sine theta is 1 over cosecant theta, and cosecant theta is 1 over sine theta. They're reciprocals of each other. Likewise, cosine theta is 1 over secant theta, and secant theta is 1 over cosine theta. And finally, tangent theta is 1 over cotangent theta, and cotangent theta is 1 over tangent theta. So those are the reciprocals. What about the quotient ones? I said there were 2 of those. Yep. One of them is that tangent could be written as sine over cosine. And cotangent is the reciprocal of tangent, see? So we can write cosine theta over sine theta. All right, so gotta know, gotta know, gotta know. Next, a word on notation. When I see sine squared theta, preferably I'd see it like this, but you could very well see it like that. When I see sine squared theta, what's important for me to recognize is that this is not sine of theta squared. No, that's not this. This is in fact equal to sine theta being squared. Okay? So when I see these, I understand sine is being squared, not the angle. The function is being squared. Okay? All right. So, Pythagoreans. What are our Pythagorean identities? Well, I derived these, I believe, in an earlier video. So I'm just going to write them down now. Sine squared plus cosine squared equals 1. And remember, you need to know the other versions of this. And by version, I mean like I used to think for years that students, if they knew this, would then recognize that sine squared theta is 1 minus cosine squared theta. But no, it turns out that many, many, many students don't see this when they look at that. So as a result, I have learned to tell students, oh my goodness, you're going to see this a lot, and you better know that that's sine squared. Or you're going to see cosine squared, and you're going to need to rewrite that as 1 minus sine squared. So not just this one, but these two you must also know. And if we took everything here and divided by sine squared, we'd have 1 plus cotangent squared equals cosecant squared. Cool. And of course, there are two other written versions of that, right? Like I could subtract 1 from both sides and see that cotangent squared equals cosecant squared theta minus 1. Or I could subtract cotangent squared from both sides and have 1 equals cosecant squared theta minus cotangent squared theta. Okay? But what if we took this and instead of dividing everything by sine squared, we divided everything here by cosine squared? Okay, so what's that going to look like? Sine squared divided by cosine squared is tangent squared, plus cosine squared divided by cosine squared is 1, and 1 divided by cosine squared is secant squared. And again, not only do I need to know that, but I need to know the rewritten versions of it as well. I need to know that secant squared minus tangent squared equals 1, and I need to know that tangent squared equals secant squared minus 1. So please make sure you're comfortable with your identities. All right, now let's use those identities, okay? Let's use them. And we want to simplify is generally what we see as notes here, or maybe in this case we'll say something like show or verify. And so I'm told here that tangent theta times cotangent theta equals 1. And because I know my reciprocal identities, I could get rid of this and say that's, well, I know my reciprocal identities, and cotangent is 1 over tangent. Oh, look. And I really do get the one that I'm supposed to, okay? How about this one? Tangent theta times cosine theta equals sine theta. How can I show that this will equal that if I simplify? Well, you know, one of our strategies, and we'll have quite the list, 8 or 9 things in chapter 5. One of our strategies for taking care of problems like this is to rewrite in terms of sine and cosine. So tangent, well, I know that tangent is sine theta over cosine theta times cosine equals sine. Oh, look. Isn't that nice? And I'm left with sine theta equals exactly what I wanted it to be. Cool. How about this one? What would we do here? 1 plus cosine theta times 1 minus cosine theta. And we're supposed to show that this is sine squared theta. Why don't you pause the video and take a moment to show that? Hey, welcome back. One of the things I wanted to say was, this is what I'm trying to show this is equal to. So it's not an equal like I'm going to subtract 1 from both sides of the equation. It might be better to say something like that, a little arrow. Just that this is somehow going to lead us to this, and you're the one who's going to show us how. Well, this is two binomials being multiplied together. In fact, it's a difference of squares. 1 plus cosine theta minus cosine theta minus cosine squared theta. These middle terms are opposites, so they cancel. Ooh, 1 minus cosine squared. What's that? That's right. That's one of those rewritten Pythagorean identities. That one is sine squared. And then we're done, because that's what we were trying to make. Okay? All right. How about this one? Sine theta over cosine theta plus cosine theta over sine theta. And I'm supposed to turn that into cosecant theta, secant theta. Give it a try. Okay, how'd it go? Another one of those strategies that we're going to be talking about is make a common denominator. When do I want to make a common denominator? Well, I got two things joined with addition here, but I only got one thing over here, so I must have combined them somehow. Okay, so let's make that common denominator. This needs sine over sine, and this needs cosine over cosine. So sine times sine, sine squared, plus cosine times cosine, cosine squared, and our common denominator, sine theta, cosine theta. Okay? All right. Hey, what's that? It's our first Pythagorean identity. That's equal to 1. But if I don't know my identities, I'm never going to recognize that that's 1. So please make sure you know your identities. Okay, now this is where we are, and this is where we want to be. And for a lot of students, they have a difficult time going from here to here. And so what I want to suggest is maybe it's still only one object because we've got multiplication here. But if I sort of split that a little bit, I can recognize that 1 over sine is cosecant theta, and 1 over cosine is secant theta. And then I'm done, because, yep, I'm multiplying those together. So, don't worry if you're not feeling wicked comfortable with this yet. Really, we're going to spend like half a unit doing problems like that, but not for a while. This is just a first little taste of it, okay? So let's get to talking about some right triangle problems. I don't think there's going to be anything here that's harder than what you did in geometry. We have a little balloon. Here is U. And curiously, the distance between you and the balloon is 15 meters, and the angle of elevation, right? That's your eyeball. Your eyeball is looking, and you have to elevate your eye to see the balloon. Angle of elevation. Now, if you were up here on the balloon, looking down, that you somehow, that would be the angle of depression. And the cool thing about the angle of elevation and the angle of depression is, well, do you see it? Parallel lines cut by a transversal, alternate interior angles are congruent. So the angle of elevation and the angle of depression are equal to each other. Okay? I mean, I don't particularly need it to know that for this problem, but yeah, you're here. This is the angle of elevation, and in this problem, we're told the angle of elevation is 75 degrees. And what I'd like to do is figure out how high is the balloon. And the way we go about doing that is saying, okay, I got this picture. I'm looking for h. I know this angle. I know this is the hypotenuse. If this is the hypotenuse, this is the opposite side. Goodness, what trig function uses opposite and hypotenuse? That's right, sine. Sine of theta is opposite over hypotenuse. So I want the sine of 75 degrees, and that will equal h over 15. Now, notice that says degrees. Mode, make sure it's in degrees. Okay? So how do I get h by itself? Well, I just have to multiply both sides by 15. So 15 sine 75. 15 sine 75. And I get that h equals 14.490. And these are meters. All right. How about this one? What if, this is actually, I've seen people do stuff like this, where, say this is a river, and because it's red, well, you could call it the Red River, or you could call it the dramatic river of blood, or the V8 River. So, we're trying to find out how far across it is on this river without actually bringing a piece of string over there. And so what we're going to do is draw a triangle. We're going to be here, and then we're going to walk a little bit downstream. Let's say that's 50 feet until we get to this point. And then with our handy angle measuring device, we have an anklometer in our classroom fashioned from a piece of string with a weight and a protractor. And really, that's about all you need for this kind of thing. There's lots of surveying equipment that'll, take care of finding this angle for us, because at the end of that 50-foot walk, we want to look back over here when we were just, perpendicular shortest distance, and we measure this angle as 54 degrees. And I'd like to know how wide the river is. Okay, so which trig function uses opposite and adjacent? Opposite over adjacent. Ooh, that's like sine over cosine. If that's tangent. Tangent of, we know the angle. Tangent of 54 degrees is equal to opposite over adjacent. And so if I want to solve for this distance across the river, all I need to do is multiply both sides by 50 and then reach for the calculator. 50, 10, 54. And I get that the river is 68.819, and these are feet. Okay? Fabulous. Fabulous, fabulous. So, right triangles, we should expect to see these things. Now, about that angle of depression, let's imagine that you take a summer job on the coast at the lighthouse. And then, you're up there standing on duty, and you see over here a little sailboat. And suddenly, much to your horror, a giant shark comes out of the water, and oh, it's nasty. Yeah, big fin. And you wonder idly to yourself, sitting atop of your 50-foot tower, when you look out and down at the scene of horror, the angle of depression this is the angle of depression. It's funny because even though I'm going to tell you now that this is the angle of depression, I bet something like 15% of you are going to say that that's the angle of depression. No, that is not the angle of depression. Think about the angle of depression as you looking straight out and then you depress your eyes or depress your head so you can see the scene of carnage. Right. This is the angle of depression. And we know that the angle of depression and the angle of elevation are always, always, always the same because these lines are parallel, cut by this transversal. Okay? So, what we'd like to know is how far away is the scary shark from the entrance to our lighthouse? The last thing I want for my day, especially after I've watched someone else get eaten by a giant shark, is in fact to not get eaten myself. So, let's see what we can do here. I'm looking for this side. I know this side. Ooh, and that angle of depression, it was 30 degrees. So the angle of elevation, the shark looking up at you with its glassy eyes. 30 degrees for them to look up at you. So what trig function can I use? I know the opposite side. I'm looking for the adjacent side. Yeah, opposite over adjacent, sure, that's tangent. So the tangent of 30 is 50 over d. Now, mind you, I want to know what d is. So I better solve this equation so we can see d equals. Great, that cancels. Oh, but wait. I don't want a tangent over here. I just want d by itself. So I'm also going to divide by tangent 30. So what's d equal? Okay, so we've got 50, 10, 30. And I get 28.868 feet away. That's really close. I mean, that's really close. I don't want to be anywhere near that. Yeah, I would have thought that was a greater distance. Yikes. Watch out for sharks. Okay. So, we'll experience some of this tricky goodness in triangle problems. Here's sort of a variation on that. We have this ramp, and we want it to go from the ground up to a loading dock, and that distance is 4 feet. And we know that the ramp itself is 18 feet. And what we'd like to know is, what's this angle? What's this angle here? And you may think that this is something that you never do. Literally, one of my former students, in fact, engineers ramps and handicap lift elevators for a small company in town. So no, really, this is a thing. Okay, so which trig function can we use in this situation? I'm looking for theta. I know the opposite side, and I know the hypotenuse. What trig function could that be? Opposite and hypotenuse. That's going to be sine of theta equals 4 over 18. But remember, we don't want sine of theta. We want theta. And to get there, I'm going to have to get rid of this. Am I going to divide both sides by the letters sin? That's correct. I'm not going to do that. Instead, this is where we use the inverse trig functions. If I'm looking for an angle, I better be using my inverse trig functions. That's what gets theta by itself. Okay, well, let's see what we got. Inverse sine of 2 divided by 9. And I get theta is 12.840 degrees. Okie doke. All right. Well, how about this? How about this? If someone tells me that the cosine of theta is 1/2, This is something I know on my unit circle. When is the x value? For what angle is the x coordinate on the unit circle equal to 1/2? And I say, well, that's pi over 3, because I know my unit circle. I know that cosine is the x coordinate, and I know when does cosine have a value of 1/2? At pi over 3. That's right, there's a second solution. And that's 5 pi over 3. There are two places on our unit circle where the x value is 1/2, and that's at these two angles. But what if instead of getting a unit circle friendly question like this, we had something like, hey, cosine of theta equals 0.9848. And I've been asked to solve for theta. So how do I solve this equation for theta? What do I need to do there? Did you say take the inverse cosine of both sides? I hope so, because that's what you need to do. Here, cosine and inverse cosine cancel, and we're left with theta is equal to cosine inverse 0.9848. All right, well, let's see what that's going to be. Inverse cosine 0.9848, and I get that theta should equal 10.003 degrees. Nice. That's good. Why don't you try this one? Sine of theta equals 0.3746. Find theta. Okay, pause the video, give that a try. Excellent. Did you take the inverse sine of both sides? And if you do, you should end up with inverse sine 0.3746. I have a bad symbol there. 0.3746. And so theta equals 21.99959.256. Well, you know, if I had had more decimal points here, I'm thinking this was maybe supposed to get us to 22 degrees. And in fact, if we round to 3 decimal places, it is 22 degrees. Okay, but don't randomly round things, huh? Just always to 3 places. Good. So, hey, speaking of using your calculator to evaluate, how are you going to do this? The cosine of 16 degrees, 18 minutes. Well, you know, I think I kind of want to convert that to decimal. So that's 16. Ooh, where was that degree symbol? Oh, yeah, it was under angle. There it is. And then 18. Ooh, and I need the minutes. Didn't I just see that there? Yep. And so 16 degrees, 18 minutes is going to be 16.3. Great. And then I want the cosine of that. Cosine of 16.3. And in fact, you could do the problem this way and say cosine of 16 degrees, 18 minutes is 0.9598, which I guess is 0.960 if I round to 3 places. Now, this is the cosine value. This is not radians. This is a side length. Side length, I tell you. So I'm looking at this right triangle. They tell me that this is 16 degrees and 18 minutes. And what I know is that this, 0.960, if this is 1. Yeah, cosine is adjacent over hypotenuse, and look, we got 0.960. There it is. So this is the situation I'm talking about. This answer is not degrees, it's not radians, this is not an angle, it's a side length. I knew that the cosine of that angle was equal to 0.9598, and that allowed me to, that's what I was finding out. Yeah, just the cosine. I'll move on to the next one. So how are we going to figure this out? Cosecant, 73 degrees, 56 minutes. How do we do that? Any thoughts? Well, I remember that cosecant is the same as 1 over sine. So let's say 1 divided by sine of this. 1 divided by sine of, look, a little parenthesis, 73, I need that degree symbol, second angle, and 56 second angle minutes. And so we get 1.045. No, 1. There we go. And again, this is not an angle. This is a side ratio. Good. What if instead of this we had cosine of 4 degrees, 50 minutes, and 15 seconds? Well, I know when I see this, I'm going to be pulling out my calculator. Cosine of 4 degrees, you know where that is. 50 minutes, we know where minutes is. 15 seconds. There were no seconds here. See, no seconds. So that's not where they are. Oh, right, they're over here. Do you see right above the plus sign in green? So we're going to need the green button. Alpha plus sign. And so we've got our seconds. So that turns out to be 0.9964, or just 996 when we round to 3 places. So you need to be able to evaluate using your calculator. Now, you also need to be able to do some evaluating without your calculator, as I alluded to earlier. So let's say that the cosine of theta is root 2 over 2, and let's say that all our thetas live on 0 to pi over 2. So all of our thetas have to be acute, right? We're only looking in quadrant 1, from 0 to pi over 2. Okay, so for what angle is the overness, or x value, root 2 over 2? So when is the overness root 2 over 2? Well, I know that happens at pi over 4. Yeah, no, I'm not doing the inverse cosine here, because I don't need a calculator if I know my unit circle values. How about sine of theta equals root 3 over 2? What do you get for that? 5, 4, 3, 2, 1. So sine, the y value, is root 3 over 2. Well, that happens at 2 pi over 3 and at 1 pi over 3. But since we're stopping at pi over 2, we only have one answer here, and that's pi over 3. 2 pi over 3, while it has this y value, is bigger than pi over 2. Okay. And C, how about tangent of theta equals 1? We're looking to find out what angle has a tangent of 1. So I know that tangent is sine over cosine. And what has to be true about these values if our answer is 1? Well, if I take this and divide it by that and the result is 1, these things are the same. And that's another way of saying when the y value equals the x value in your ordered pair. When does that happen? Oh, right, that happens at pi over 4 and 5 pi over 4. But because we're stopping at pi over 2, we can never get to 5 pi over 4. We only get one solution, the solution at pi over 4. Okay? What if they gave us tangent theta equal to root 3? And we're still looking only for solutions on 0 to pi over 2. So there's generally going to be only one solution for us in these problems. So, yeah, I don't recognize that from the unit circle. Well, but I remember that tangent is sine theta over cosine theta. And so I guess I could write that like that. And while it's true cosine is equal to 1 when the angle is 0, yeah, I'm not recognizing this. And in fact, square root of 3 is bigger than 1, and sine values are between -1 and 1. So there's no way that could be. But wait a second, we've seen root 3's on our unit circle, provided they're root 3 over 2. Well, if I divide the top by 2, I'm going to divide the bottom by 2. And so I'm looking for when is the y value root 3 over 2 and the x value 1/2. That happens at pi over 3. Okay? What if we had cotangent? No, I want secant. What if we have secant of theta equals root 2? How do we solve this? What theta has a secant value of root 2? And it may help to write this like this, because I know that cosine is in fact the reciprocal. And if I rationalize here, I end up with cosine theta equals root 2 over 2. I know root 2 over 2, that happens when theta is pi over 4. It would also happen for cosine at 7 pi over 4, but since we're only looking in first quadrant, we only have this one answer. Okay? How about this one? Sine of theta equals -1. Well, I know sine is the y value, and on the unit circle, the y value is -1 when theta equals 3 pi over 2. Oh, no, that's wrong. How come? Because we have this restriction. We're only looking in first quadrant. This is way bigger than first quadrant. We are here to here only, but our answer is that angle. No, you can't get past that wall. Sorry, this is no solution. So please pay attention. This information is given for a reason so that you know you can actually stay within it. All right. Well, that's it for today. I hope that was a useful review for you. And tomorrow we'll be starting our last section of this unit before we get to our assessment.